So we're now going to walk through the implementation of the Zippy Microservice, and I'm going to show how we can implement the ZippyApplication, the ZippyController, and the ZippyService classes, as well as the custom SQL query mechanism. And this will show us how you can encapsulate the Jakarta Persistence API with the reactive types. So it looks reactive from a client's point of view, but the implementation leverages the more traditional way of doing things with the JPA. And you can find this in the EX3 project in my WebFlux folder, in my live lessons GitHub repository, and this is all nestled way down here in some files that are found at the end of a long path. So here we are in project EX3. Let's go look at Zippy Microservice. Let's come down here. A couple things to note. Let's start off with sort of the declarative portion of all this stuff. This is also the same pretty much for the handy microservice, just a few little tweaks. So you can see here that we give the port number the value of 0. And what that says is, please use the Eureka discovery service to assign a port and notify the discovery service of the port that we're setting up. We are a Eureka client. That's true. Our name is Zippy. And we're going to use this particular database driver, the H2 driver, which is the Hibernate driver. And you can see we're going to use this with the so-called JDBC, Java Database Controller tag. And it's going to be an in-memory database. And we're going to have the table in here is going to be called quote. And these are just some other things that we use to set the version of the database to use with the JPA. So that's just the declarative stuff. Here is the schema we're going to have for the contents of the Zippy database. And you can see here we have a primary key, which is going to auto-increment. So every time we put something in the database, it's going to automatically update the key by 1. And we also contain a quote, which is going to be a character array that's got no more than 1,024 characters. Down here, we have the actual data. And this is how we can insert stuff. There's all kinds of different ways to insert things into databases. This is a pretty simple way that works if you don't have a ridiculously gigantic database with lots of entries. So you can see we're going to insert into the quote table all these quotes. And each quote is going to have some silly Zippy the Pinhead statement. And it'll auto-increment the database, so we don't actually have to do that explicitly. So that's how we declaratively configure this stuff. Over here, you can see in the ZippyApplication, we say that we're going to be using the Zippy quote repository, which is the JPA repository, and it's going to contain quotes. And we've looked at quotes before. The quotes occur way up in a different part of the program altogether in the common module. And then we extend the base application, have a run method that we inherit from the base application, and that goes ahead and starts things up and does the auto wiring and so on. If we want to get a dump of the contents of the database when the program starts, we can uncomment this method and make it a bean. So it wasn't a bean before, so it wouldn't be used. But by making this a bean, then when the program starts, it'll dump the contents of the quote database, which is a very good debugging technique to be aware of if you're not quite sure why things aren't working, to do something like that. The base application, if you recall the base application, that was something that also came from the common part. That made the run method we saw, and it also made things work with virtual threads. So we don't have to rewrite that code. Great example of don't repeat yourself. OK, so that is the Zippy application. The ZippyController, really not a whole lot to say here. We've seen this a gazillion times. The main thing I'll just note in passing is we use fluxes as the return types here. And that's going to enable us to interact with the client as if this was a completely reactive microservice, even though we know it's not. The controller methods just forward to the service methods, which are auto-wired together. Here's the service implementation. You can see what it does is it just calls into the underlying JPA-based database, returns the list of all the quotes, in this case, turns them into a flux. Do the same thing, looking things up by their quote IDs. Here's where we're going to do searching using a parallel flux. This is probably something that's important to remember because you'll need to know how to do that at some point. And so you can see here that we're going to convert the list to a flux. So we take the queries, turn it into a parallel flux, run it on the bounded elastic scheduler. We could probably get away with not using bounded elastic because it is an in-memory database, but this doesn't really hurt anything. And then we take the results of this and we use flat map. It's perfectly OK to use flat map in the context of Project Reactor because it doesn't have the limitations that we do with parallel streams. And what we do is we then find the quote containing the query by looking it up in the database. And we're going to essentially flat map all those things together, turn the parallel flux back into a sequential flux, and then eliminate duplicate quotes so we don't have duplicates returned. So very, very similar to using Java parallel streams, except we don't have to worry about using map multi. We can use flat map because that doesn't have the limitations that parallel streams does on flat map with parallel streams. And then the last method here is the search EX method, which is going to call down to the find all by quote containing ignore case all in custom query. And we're going to turn that into a flux. It's not a stream. We turn it into a flux. Make sure I say that up here. Good. OK, so that is kind of the wrapper of all this stuff. And then the implementation that matters here is the Zippy quote repository, which, as we saw before, is going to extend JPA repository and multi-query repository, define one method using Spring's data API keywords, so that's automatically generated. And then we have the multi-query repository where we implement the actual details of this. And I won't spend a lot of time on this because we've gone through it before, but the first part here is just setting things up so we can have an entity manager that we can do queries on. And then we call a method called getPredicate, which takes the list of queries, the criteria builder, and our quote expression, which is really just the particular column or field we want to do the work on. And that builds an AND predicate. We've looked at this before, too, so just very quick. We convert the list of strings into a stream of strings. We map them to lowercase. We then go ahead and make this criteria builder like predicate that will match the quote field of the quote entity. So we'll have a bunch of those. And then we're going to reduce them all together using the AND operator. And we're going to make a conjunction. So this is going to return a predicate that will do an AND of, it'll match things if everything in the string matches in, everything in the list of queries matches the string. And then we pass that to get query results. And that will create the query with the AND predicate grouping by the quote expression to get rid of duplicates. You'll notice we don't sort the results here. Your implementations have to sort, but that's an easy fix. And then we go ahead and execute the query and return the list. And that, of course, comes back as a list. And the ZippyService will then convert that list into a flux. And that is what gets returned to the client. So that's the code. It's a bit duplicative of what we talked about before with a little twist of making things work with fluxes as the return type.